Okay, hello everyone. Welcome to Q Physics Academy. So, uh, Q Physics Academy have to start semester 4 lectures for Vidyasagar University. Okay, and this lecture is basically based on for the major course. What taking who was taken the major course in your throughout the 4 year 4 year BSc honors course. So if those students are already first semester 3, congratulations and all the best for your new semester. Mm, I hope as like third semester 3, in the semester 4 you will study your you give your effort. If you give your effort, okay. So so my suggestions is keep motivated and keep learning, as like first year, second year and third year. So this is the semester 4. Here we have to learn many important physics. Okay, so you have a two subject. Okay, you have a one major course that is called measure 5, right? That is called measure 5. So in measure 5 we have a basically two units. Okay, we have a two units, atomic and mathematical physics 3 and atomic and mathematical physics 3. So in the atomic physics part you have to learn about some basic introductions of quantum mechanics, hydrogen like atoms and hydrogen atom and their fine structure as well. So we'll discuss in later throughout in my channels. And also you have to learn about the mathematical physics 3. Here have some important topics regarding one is so today's lectures is based on mathematical physics 3. So I have to start with mathematical physics 3. Okay, so in the mathematical physics 3 there have a two broad topics. Okay, so there have a two broad topics. So one is basically complex analysis, that is very important. Complex analysis. And the second topics is mathematical second order mathematical differential equations. Second order differential equations. Okay, second order differential equations. So basically in this case in the broad topics we have to cover some base legendary polynomials, legendary polynomials and Hermite polynomials. Also we have study about the power series method, power series solutions. Okay, and power series solutions. So these are the very Taylor series expansions, etc. and Lorentz series as well. So now my aim in the now I am now I am taking one topics, right, that is called complex analysis. So in the complex analysis part there are a lot of things. Okay, so first of all I want to figure out what are the important topics are actually there, and those important topics are very important to structure our course and understand, and also understand broadly what actually included here. So in the mathematical physics class, just give me some times. Yeah, I got the syllabus from your website. Yes, that is unit 2 mathematical methods 3. So our main topics is now complex analysis. Okay, so we have to cover here complex analysis. So first of all, complex analysis. Okay, so in the complex analysis part, there are many subtopics. Okay, so 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 the mentioned subtopics, I just give you some figure what actually you want to study throughout the lectures actually. So here we study about the complex number and study some complex number. Second point, we have to study the Euler's formula, that is very very important. Okay, Euler's formula. Euler's formula. Third topic is De Moivre's theorems. De Moivre's theorem. De Moivre's theorem. And third topic is root of complex number. So root of complex number. Root of complex number. Now the topic number 5 is functions of complex variables. Okay, functions of complex variable. Topic number 6, we study the topic 1, topic 1 to 5. These are some basic definitions of complex algebra actually. So now now using those definitions, we have to study some advanced topics as well. So the topics are basically analyticity of analyticity and Cauchy Riemann conditions. That is very very important. Okay, that's are the advanced topics. Analyticity and Cauchy Riemann conditions. Riemann conditions. Okay, and also we study some examples also some examples we have to study, don't worry. So topic number 7 is next very important topics is singularity. We have to study about the singularity. So that is another important topics in complex analysis. So we have to study singularity, types of singularity, branch cut, branch points. Okay, so let's add with branch points, branch cut. These are the important topics. Okay, so topic number 8 is very important, Cauchy integral theorem. Cauchy integral theorem. Okay, which is integral theorem. So it is also another important theorem is here. You have to study. Next, the topic number 9 is very very important. So that is nothing but Taylor series and Lorentz series expansions. And Lorentz series expansions. So it is very very important. Okay, every year every kinds of exams, from the perspective of competitive exams, from the perspective of semester exam, they always asked from these topics 1 or 2 questions, and the top questions are very easy. But to solve those questions, you have to learn about the fundamentals of complex analysis first of all. Okay, so we have to throughout the course we are learning many things one by one and build our concept in very strong. Okay, so this is the Lorentz series expansions. and now, sorry, so my phone is ringing, so sorry, that's for that. So now the question or subtopics number 10 is basically the residue calculations, and the very very important residue and residue theorems actually. So we have to start with the residues theorem, residues and residues theorem. Okay, so those are the important topics. Okay, those are the important topics of complex analysis I have to cover throughout my course. So so what strategy we have to follow throughout my course, that is very very important. We have to cover the basic as well as some advanced and some competitive exam. We are taking some university level questions, and we are also taking some we are many times lot of time taking the competitive exam type questions like jam jest. Okay, jam jest. So this course is a unique course. So this course is not only for the semester BSc semester 4 level course. This course is also important who are preparing and who will preparing in future for the national level exams like IIT JAM, JAST, TFL, and further NEET, GATE, JAST, etc. Okay, so this course is basically a unique course, and this is a kinds of a bucket where all components are actually incorporated here, right? Okay, so certainly I will focus the basic part in basic parts also. So so I have to make sure that this course is very very important for who are in semester 4. Okay, who are very semester 4. Okay, so let's start with let's start with the first topic, that is complex number. So we are already familiar with complex numbers, right? So we're already familiar with complex number, right? So complex number is nothing but a number which consists of two real number, a real number and an imaginary number. So basically a complex number is represented by z, and it is written as x equals to 1 plus iy, where this term is the real and this is the imaginary number. Okay, imaginary number. So here I is called here I have a value root I is root I is equals to have value some I square is equals to value minus 1. That's I mean, okay. So I is equal I square is have a value minus 1. So here I have value I square equals to minus 1. So I equals to basically root under minus 1. So these are the basic you was already studies in your class 12 course. Here also x and y are real number. Okay, x and y are the real number. So first of all, okay, let's take some graphical representations of complex number. Okay, graphical representations of complex number. So okay, so we are already know some taking some complex number. Okay, let us take a complex number, that is 3 plus 4i into plus 5 plus 2i. Okay, so this is a kind of complex number, so I have to simplify this. So this is equals to 3 plus 4i plus 5 plus 2i. So here we are adding the real number with imaginary number. So basically 3 plus 5 plus I 4 plus 2. So that is equals to 8 plus I 6i. So it's a real again so when two complex number is add with each other, so you get another complex number, right? Okay, so first of all I want to represent this real number in a graphical way. Okay, so to represent this complex number in a graphical way, first of all need to understand the graphical representations of individual complex number. So what I mean is actually individual quantum number, that is the individual complex number. So there are two complex number, right? So here this complex number is called Z1, that is equals to 3 plus 4y, and the another one is called Z2, 5 plus 2y. So actually here Z is nothing but the resultant of two complex number. Okay, so it is nothing but the resultant of two complex number. Understood? So first of all we are here to represent the complex number, two complex number Z1 and Z2. So this is the axis X and this is the axis Y. Okay, I means imaginary axis IY. Okay, so that is nothing but a IY. So this is the real axis, this is the real axis, and this is the imaginary axis, and the plane is called complex planes. Okay, and the plane is called complex planes. So it is nothing but a complex plane. Okay, so it is nothing but called complex planes. Okay, so this is the origins. It is it's taking O. So now we first of all represent the what is the representation of Z1. So Z1 is nothing but 3 plus 4i. So okay, so in the real axis we are going to point 3, and in the imaginary axis we are going to plus 4i. So let's say this is the point is actually represented by Z1. Okay, and it is nothing but 3 4i. Understood? So this is nothing but 3 4i. So the representations of this complex number is nothing but this is. Okay, another case, another representation is 5 plus 2y. So let's going to in the real axis, that is the 5, and we are going to in the imaginary side 2 scale. Okay, 2i. So this is the point, that is Z2, and it is 5 comma 2i. Okay, so these are the two complex number graphical representations in a complex plane. So now the resultant of these two resultant of this two complex number is nothing but 8 plus 6i. Okay, so 8 plus 6i, so let's say this is the point 8 and 6 is taking, yeah, you're taking here. So this is the point is actually Z, that is 8 6i. Okay, so this is the actually resultant of this two complex number. Okay, so it's a kinds of vector addition. It's a kinds of vector additions. Okay, so this is the kinds of graphical representations of the complex number. Let's take another complex number to understand in properly how to represent a complex number in a graphical way. Okay, so let's take another, that is b z is equals to 6 minus 2i minus 2 minus 5i. Okay, so here again z1 is nothing but 6 minus 2i and z2 is nothing but 2 minus 5y. Here we are now subtracting this two complex number. So what do you get actually? So 6 minus 2 minus 2i plus 5y, so that is equals to 4. Yeah, so it is equals to plus 3i. Okay, so this is the another representations of two complex number, and I want to represent here in a graphical way. So this is the real axis and this is the y, that is imaginary axis, actually imaginary axis. Okay, and this is the origins. So first of all we are represent the first complex number z1, that is it is going in the real axis in 6 scale or 6 unit. Okay, let's take 1 unit, 2 unit, 3 unit, 4 unit, 5 unit, 6 unit, and it's going in the negative imaginary axis 2 unit. Okay, so 1 2, yeah, fine. So let's take, this is the point and that is z1. Yeah, okay, I hope you understood. Next point, it's a kind of minus 2 plus 5i. Okay, minus 2 plus 5i, minus 2 plus 5i, z2 is nothing but minus 2 plus 5i. Okay, so minus 2, so minus 2 plus 5i. Yeah, so the point z2. So now I'm going to represent the resultant. So resultant is nothing but here 1 2 3 4 and 3 here. Okay, understood. So this is nothing but z equals to 4 plus 3i, z1 is equals to 6 minus 2i, z2 equals to minus 2 plus 5i. So these are the actually graphical representations of a complex number. I hope you understand. Now let's take some problems to understand to understand better the complex number theory actually. So okay, let's take a questions. Let's take questions. Okay. So prove that a mod of z1 plus z2 is less than equals to mod of z1 plus mod of z2. So actually these are the some fundamental algebra of complex numbers. Okay, so you have to remember this all fundamental algebra. So this is the proof A. Let's prove V, that is mod of z1 plus z2 plus z3, again that is equals to mod of z1 plus mod of z2 plus mod of z3. Okay, I hope you understand. How can I so this is the actually fundamental algebra of complex number. So I have to prove. Okay, I have to prove. Okay, so one thing you remember, the students are, if you know in your semester exams they asked prove that the question B. Okay, prove that the question B. So how can you solve that? That is very very important. And again also if they asked prove the question A. So how can you prove this kind of algebra, fundamental principle of complex number? Okay, so that is important also. So okay, let's prove one by one. So let us take two complex number. Okay, let's take two complex number. Let us consider two complex number. So we already know about complex number, that is z1 is equals to x1 I y1 and z2 equals to x2 plus I y2, where x1 y1 x2 y2 are all real number. Okay, where x1 y1 x2 y2 are belongs to real number, Okay, let's first of all add these two complex number z1 plus z2. So we already know about the how can I add these two complex number. So x1 plus I y1 plus x2 plus I y2. So we add real to real, real with real. So x1 plus x2 plus I y1 plus y2. Okay, so we get x1 plus x2 plus y1 y1 plus y2. So that is consider, that is equation number 1 and that is equation number 2. Okay, now let's take the modulus of this complex number z1 plus z2. It's a kinds of complex number. So we already know how can I calculate the modulus of a complex number. We take the square of the square of this two real number and add them, right? So mod of z1 plus z2 is equals to root under x1 plus x2 whole square plus y1 plus y2 whole square, and that is equation number 3. Okay, okay, okay. Now we have a known properties. We have a known properties each root under x1 plus x2 whole square plus y1 plus y2 whole square. It's a kinds of it's equals to actually is less than equals to x1 square y1 square plus x2 square plus y2 square. I hope you already learned about that in your school level standard. Okay, so now this square these equations. This is equation number 4. Now squaring equations 4 both side. Okay, so what do you get actually? We get x1 minus whole square plus y1 minus y2 whole square, and that is equals to root under x1 square y1 square x2 square plus y2 square whole square. Okay, so it is equals to actually we get x1 square x2 square plus 2x1 x2 plus y1 square y2 square plus 2 y1 y2 and less than equals to x1 square plus y1 square plus 2 into x1 square plus y1 square root under x2 square plus y2 square plus x2 square plus y2 square. Okay, now comparing both sides, the x1 square x1 square x2 square x2 square and y1 square y1 square is cancel each other. Okay, this values are cancel each others. So now what we get that is 2 x1 x2 y1 y2 less than equals to 2 root under x1 square x1 square y1 square into x2 square plus y2 square. So 2 cancel each others. Okay, so what do you get? I get x1 x2 y1 y2 less than equals to mod of x1 square y1 square x2 square y2 square. Okay, now again squaring both sides, that is equation number 5. Okay, now again squaring equation number 5. What you get? x1 square x2 square plus y1 square y2 square 2x1 x2 y1 y2 less than equals to x1 square plus y1 square into x2 square plus y2 square. Okay, so it is equals to x1 square x2 square plus 1 square y2 square 2x1 x2 y1 y2 that is equals to x1 square x2 square plus x1 square y2 square plus x2 square y1 square plus y1 square y2 square. So again comparing the both side cancel each other's, this x1 x2 square x1 x2 square y1 y2 square, y1 y2 square. So what do we get finally? Finally we get 2x1 x2 y1 y2, that is equals to mod of x1 square y2 square y1 square x2 square. Okay, yeah, so it is equals to actually, if I yeah, it is equals to actually 0 less than equals to x1 square y2 square minus 2 x1 y1 y2 y2 oh sorry y1 x2 y1 x2 plus y1 x2 square. Okay, so it is equals to actually x1 y2 minus x2 y1 mod square other than equals to 0. Yeah, which is true, which is true, right? So right, so it's true always any square and positive number, so it is true, right? It is true because squaring of this any number, it's always greater than 0, and it should be greater than equal to 0. Yeah, this condition is true. So what can we write? So is it is true, is it is true, we are easily right, we are easily right. So it means that is mod of z1 plus z2 is less than equals to mod of z1 plus mod of z2. It's proved. So to prove this kind of fundamental principle, fundamental algebra, so you can follow the some basic principles of 6 steps. Actually you can follow some basic steps. Now we have proved the questions B. So questions B is nothing but z1 plus z2 plus z3. Okay, it is equals to, we can write is like that, mod of z1 plus z2 plus z3. Okay, z2 plus z3. So it's a kind of that is equals to mod of z1 plus mod of z2 plus z3. Okay, so again z2 plus z3 you already know from equations, using equations A. So it is equals to mod of z1 plus z2 plus z3. Okay, so it is again proof. So I actually use here the properties of equations A. Okay, use properties of questions A, sorry, of questions A. Okay, so it's proved, right? I hope you understood. I hope you understand how can I, so how can we, I can you solve this kind of algebra of complex number. Okay, okay, so next going to the theory is Euler's formula. Okay, Euler's formula. So to prove that Euler's formula, we use the infinite series expansion of exponential infinite series. So we have infinite series expansions. So it's a kind of some formula throughout the complex throughout this course. This formula is very very important or very very useful. Okay, it is used very time. It will use very time many times uh, when you solve any kinds of complex integral theorem and you solve residue theorem. So this formula is important. Okay, so today's class is basically information based. I hope from class 2 and we have to learn some concept also. Okay, so let's okay. So for the my apologies to inconvenience from this ringing on my phone. So today is basically Saturday. So some of my lab mate hmm, call me to for holidays, vacations, etc. But I am dedicated, and I am dedicated to you, to your course. Okay. So I love to teaching, so that's why I'm here. Right. So that's why I'm always saying every student, please follow, please love your passions. Otherwise, it is not possible. Okay, it's true. Many times I have not able to upload videos on my channel because due to lot of pressures, I have lot of pressures. But I had uh, but 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 when but I'm realized, what I'm realized, if I not if I not I'm not uploading videos, so my knowledge also some have also has some boundary, and also you are also the students are waiting for my lectures. So this motivations also pushed me to record the videos and upload through my channels. Yeah, that's some kinds of motivations, some motivation, some responsibility, combine both. Yes, right. Okay, let's. So what's the Euler's formula? So Euler's formula, so to derive this Euler's formula, okay, we have to start with some infinite we have to sum is start with certainly with infinite series expansion of exponential series. Okay, so we have infinite series expansions e to the power x. So we have already know 1 plus x squared 2 factorial plus x squared 3 factorial and so on. Okay, so let's put here, let's take that is equation number 8. Now put in equation number 8 x equals to I theta. Okay, let's put in equations 8 x equals to I theta. So we get e to the power I theta equals to 1 plus I theta plus I theta whole square by 2 factorial plus whole cube by 3 factorial plus and so on. So that is equals to 1 plus I theta, and we are already know I square equals to minus 1. Okay, so I have already mentioned. Okay, so that is equals to I square equals to minus 1, so that is equals to theta square 2 factorials, so I cube is equals to again minus I. Okay, so yeah, minus I theta cube on 3 factorial plus and so on. So now e to the power I theta. So let's take separate the real values, real, and separate the imaginary values. So I get 1 minus theta square by 2 factorial plus theta to the power 4 by 4 factorial minus, and so on, and plus if I write the imaginary part, so that is equals to theta minus theta cube theta 3 factorials plus theta to the power 5 by 5 factorial minus, and so on. So now the series is looking like this is nothing but cos theta plus I, the second one looking like sin theta. So we get very important relations. So that is e to the power I theta is nothing but cos theta plus I sin theta. So yes, that is very important. So please remember. Okay, so it is a kind of Euler's formula, e to the power I theta equals to cos theta plus I sin theta. So what is the value of e to the power minus I theta? So e to the power minus I theta is nothing but cos theta minus I sin theta. So these two Euler's formulas are very important. So please keep in mind every time when you solve any complex number. Okay. Now this using Euler's formula, I have to find some e to the power z. So using this formula, I want to calculate e to the power z. So e to the power z equals to e to the power x plus iy, because we are already know z equals to x plus iy. So it is right at e to the power x plus into e to the power iy. So it is equals to e to the power x, and e to the power iy can be right using Euler's formula. So it is equals to cos y plus I sin y. I hope you understand how can I use this formula. Okay, so it is equals to e to the power x into cos y plus I sin y. I hope you understand. This formula is useful. Okay. So e to the power of any number, any imaginary number, okay, exponential of any imaginary number can be written as a cos theta minus I sin theta, or cos theta plus I sin theta. Okay. Yes, very good. Next I am going to discuss the de Moivre's theorem. Next I am going to discuss the de Moivre's theorems. Okay, next I am going to discuss the de Moivre's theorem, and this is the last part of the today's class actually. Okay. Okay, de Moivre's theorem. Yes, de Moivre's theorem. So if z1 equals to x1 plus iy1. Okay, so let's take x1 equals to, okay, let's take x1 equals to r1 cos theta 1 y1 equals to, in the r theta plane. Okay, actually, what is the main important of de Moivre's theorem? You have to understand when I derive the formula. Actually, from complex xy complex plane to, we convert this xy complex plane to r theta complex planes. Actually, the main aim is actually xy complex plane. So z1 actually written is here in xy complex plane. So it is represent the xy complex plane, right? Cartesian complex plane. Now this xy complex plane I have to represent in a r theta complex plane. Okay, so you already know Cartesian coordinate to polar coordinate conversion. So use this concept actually here. Sine theta 1. Okay, so let's put this value. So z1 is equals to r1 cos theta 1 plus I r1 sin theta 1. So that is equals to r1 taking common. So cos theta 1 plus I sin theta 1. That is equation number 9. I hope you understand. In a similarly, z2 can be written as r2 cos theta 2 plus I sin theta 2. That is equation number 10. Okay, now we have to multiply this two complex number z1 z2. What do you get? r1 r2 cos theta 1 plus I sin theta 1 cos theta 2 plus I sin theta 2. Okay, so r1 r2 it is equals to cos theta 1 cos theta 2 plus I cos theta 1 sin theta 2 plus I sin theta 1 cos theta 2. I is equals to minus sin theta 1 sin theta 2. Okay, so it is equals to r1 r2 is equals to cos theta 1 cos theta 2 minus sin theta 1 sin theta 2. This is part, and taking I common, cos theta 1 sin theta 2 plus sin theta 1 cos theta 2. Okay, so it is actually represented here r1 r2 is equals to cos theta 1 minus theta 2 plus I sin theta 1 minus theta 2. So okay, that is equation number 11. So in general we can written is z1 into z2 dot up to zn is equals to r1 r2 to rn equal to cos okay is equal to theta 1 plus sorry yes yeah, oh yeah, taking the minus, yes, this plus. So cos theta 1 plus cos theta 2 up to plus cos theta n plus I sin theta 1 theta 2 plus theta n. Okay, so basically if z1 z2 zn are these are equals, so there are conditions, that is equation number 12. So if certain conditions z1 z2 dot equals to zn equals to z, so then what happened? Then it is nothing but z to the power n, right? Z to the power n. If there are two value, the z square. It's a three value, the z cube. So it is equals to again r to the power n, r to the power n, and cos theta plus I sin theta whole to the power n. Okay, so it could be written as r cos theta plus sin theta whole to the power n. So okay, so it is equals to no, I have written very bad way. I take some basic, sorry. If z1 z2 all complex number are equal, so I'm going to written is r to the power n, and cos all theta 1 are equal, theta 2 theta 1 theta 2, so theta 1, so it's equals to basically n theta, right, plus I sin n theta, right? So z to the power n is nothing but r to the power n cos n theta plus I sin n theta. So which is often called de Moivre's theorem. Okay, which is often called de Moivre's theorem. So z to the power n is nothing but r to the power n cos n theta plus I sin n theta. Okay, so it is called theorem. Okay, so this is called de Moivre's theorem. So I hope you understand the complex number, Euler's formula, and de Moivre's theorem also. Next class we have to discuss some root of complex number and some complex variable and branch card, branch point, analyticity, and some singular functions, pole, branch card, etc. Anything we have to cover one by one throughout my course actually. I hope you understand these questions. Okay, so yeah, so if anyone have any kinds of doubt from the particular theory we have covered here, so please comment below, and I'll give you answer in the Saturday or Sunday. Okay, so I have a lot of research work from Monday to Friday. I am fully focused with my research also, so I'll help you only for 2 days actually. So I am available for you only for 2 days. Okay, I hope you understand. You are all are graduates. You all are become my graduate student. Okay, so you already seen. I hope you all are saw your seniors were busy with your research. So I hope you understand my situations also. Yes, and it's my request. Please understood. And okay, don't worry. I'll give you my number. So this is my number, 7029574620. So you have any kinds of doubts based on the theory I have discussed here, so you can ask, phone call, many things. So I of course I will clear your doubts. Okay, so yeah, thank you. Thank you for watching these videos, and please like and subscribe to the channels also, and share this video with friends, colleagues, etc. Okay, thank you.